A rectangular base pyramid has been cut by a plane as shown in figure 1.65. Part 1. Draw the given views. Part 2. Project an auxiliary elevation which will show the true angle the cutting plane makes with the horizontal plane. Part 3. Project a second auxiliary plan showing the true shape of the cut surface. Okay, so our first step is to decide whereabouts on our page we're going to begin our question. I have chosen to start mine on the right hand top corner. This is dictated by the two views, the two auxiliaries that will be taken later on. So I'll begin by finding my XY line, and I'm going to draw the given elevation and plan as per the question. All the information needed to draw the elevation and the plan is given, so therefore we should have no issue with this part to begin with. So I'll set out the overall width of the base of the triangle, and now I'm going to darken in the width and the length of the triangle in plan. I can tell which lines are already going in full by looking at the question, and I can tell which ones then that I can only find later on by completing the elevation or the plan, and they're going in red for the minute. The red lines again symbolize construction. The heights for the elevation are given in our question. So the overall height of the square base pyramid is 66 millimeters, and the cut starts at 58 millimeters from the horizontal plane to the extreme generator of our square base pyramid. So I'm joining the top of the apex of the square base pyramid back down to the base, which we had set out previously. And I'm also going to project the cut where it intersects the extreme generator of the square base pyramid down towards my plan, and that will give me the top point of the slice in plan view. So I'm going to label that as part 3, and I'm going to measure in 24 and down 7 on the plan to find the other 2 points that belong to that section cut, and I'm going to label those guys, or I'm going to join that to number 3, like so. And now I can put in the rest of the dark lines in my plan. I'm going to project the point 2 up to where it intersects the horizontal plane, and I'm going to do the same with point 1 after I've labelled my entire drawing. Indexing makes doing auxiliaries further down the road much more easier. It also helps with visualizing. So now that I have it all indexed and I've located the points of the cut on the horizontal plane and where it cuts on the extreme generator, which is point 3 and point 2, I'm going to join them together. Okay, so that's the first part of the question done. Our elevation is drawn and so is our plan. Now we got to find the true inclination of this slice to the horizontal plane. So we'll set up our sliding set squares to go parallel with the edge of the slice taken from our square base pyramid, and we're going to project all relevant lines parallel down our page. I'm also going to bring the corner that's in construction, because as we see later on when we're building our second auxiliary view, it just makes it easier to see when we plot that point through all views. Once I've projected all the lines parallel, I must then go perpendicular to create my new XY line. So X1, Y1. The distances for this auxiliary elevation are taken from our original elevation. So we take it from the XY line to the top to get the first height, which is the point O, the apex of our square base pyramid, and then all we have to do is plot the rest of our points. Again, I'm going to start to label my drawings, as indexing makes it much easier to visualize and to follow points from view to view. I've taken the height of the cut and I've labelled him number 3, and the other 2 parts of the cut, 2 and 1 are on the ground, I've also labelled it in. Now I can join the apex of my square base pyramid out to point D, which I know doesn't exist, so I've put in construction. I'm going to now put in the slice, so I'm going to join point 3 to point 1 and 2 and the line to the apex. I'm also going to join point O to point C, point O to point B, and point O to point A. Now A appears as a broken hidden line because we can't see it from this particular view. That there now shows our true inclination of the slice to our horizontal plane. But in order to get our true shape, we must again take a second auxiliary looking in at 90 degrees to that true inclination to the horizontal plane. So again, set your slide and set squares up to that line, and you're going to project parallel away from that drawn. Once all our lines are brought up parallel, we now need to move perpendicular to those lines in order to create a new XY line. So this is X2, Y2. So in order to get the distances or the measurements for this last auxiliary view, we count back 2 views. So we go back from the elevation back to the plan. So from the auxiliary elevation back to the plan. So from the plan to the X1, Y1 line, we'll plot our distances. Again, if you label the points, it makes it that much easier to visualize. The most important thing to remember here is that you're going back 2 views and you're working from the plan to the X1, Y1 line for your measurements. Once you have that done, it's just a matter of finding all the points and joining